Hi, I'm Sonong Park from MONITORAPP's CTI Division TI team. And this presentation is about cyber threat response strategy based on threat intelligence. And today's presentation will start with an overview of the current threat landscape and emerging trends of cybersecurity field. We will then define threat intelligence, explain why it's essential for cybersecurity, and discuss the overall intelligence framework. Next, we will explore practical applications of threat intelligence, including SOC integration, threat hunting, and incident response capabilities. Following that, I will introduce MONITORAPP's Threat Intelligence Platform, AI Labs version 504, and we will wrap up with conclusion. Starting with the overview. The currently cybersecurity landscape is becoming increasingly complex as various technologies converge. Cyber threat intelligence has also evolved to incorporate a diverse mix of technologies ranging from traditional patterns such as RRO to AI and big data. In particular, integrating core technologies such as AI-based automation and threat analysis has become critically important. These keywords are closely related to the main topics we'll talk today's presentation, and clearly show why threat intelligence is essential in our current cyber environment. First, let's see severity of the current cyber threat through major security incidents that have occurred recently. The SKT personal information breach, which became a major social issue, resulted in approximately about 26 million data being stolen. And Yes24 also suffered from ransomware attack with over 1 million users' personal information suspected to be leaked. Major services including Google and AWS experienced massive DDoS attacks through HTTP2 rapid reset attacks. And additionally, the LastPass attack caused service disruption and source code leaks. And the XE-utils backdoor incidents once again demonstrated the vulnerabilities in open source software supply chains. And especially noteworthy is the movie transfer attack by the Russian Cloak, which exploited a zero-day SQL injection vulnerability. This presents one of the most significant security incidents combining zero-day exploits, supply chain attacks, and ransomware. Now let's look at hacker groups. Numbers of hacker groups still exist these days, and the number is still growing. At the same time, the activities of major APT groups are becoming increasingly sophisticated. The Lazarus group continues to conduct attacks targeting cryptocurrency exchanges, while Kimsuki is intensifying spear phishing and smishing attacks against South Korea. APT-28 is targeting NATO and Ukraine-related organizations, and the APT-41 is conducting global attacks linked to the Chinese government. These groups are carrying out various forms of attacks, including spear phishing, zero-day exploits, and supply chain attacks. Their TTPs are becoming more advanced and diverse and making it difficult to respond with traditional security solutions alone. So far, we have talked about the background and reasons why threat intelligence is necessary. So let's talk about what is it? What is threat intelligence? Threat intelligence, as defined by Gartner, says threat intelligence is evidence-based knowledge including context, mechanisms, indicators, implications, and actionable advice about an existing or emerging menace or hazard to assets that can be used to inform decisions regarding the subject's response to that menace or hazard. So it is evidence-based knowledge about existing or emerging threats. To tell in advance, it's not merely simple information, but comprehensive intelligence that includes context, mechanisms, implications, and actionable advice. So why do we need threat intelligence now? Cyber attacks are becoming increasingly sophisticated and automated, making defense impossible through simple detection alone. Understanding attackers' intentions and method has become essential, and we must shift our paradigm from simple detection to prediction and analysis-driven security strategies with threat intelligence. Furthermore, it goes beyond simple information gathering to provide meaningful insights, helping security experts make more effective decisions. So then, what roles can threat intelligence play? Threat intelligence plays a crucial role across all areas of security operations, from establishing security policies to incident response, optimizing SOC and SIEM operations, and conducting continuous threat monitoring. In particular, AI-based threat analysis and automated response capabilities can significantly enhance the efficiency of security experts. Even after an attack has occurred, threat intelligence can facilitate post-breach detection to determine the scope of damage and establish additional security measures. And it is a picture called pyramid of pain, which is often introduced to explain intelligence. First introduced in 2013 by David J. Bianco, it is a commonly used concept to explain the effective utilization of intelligence and effective threat detection. In conclusion, lower-level indicators such as hash, values, and IP address can be easily changed by attackers, making their detection effectiveness limited. But TTPs, such as tactics, techniques, and procedures, and tools and network artifacts can be difficult for attackers to change, making more effective detection possible. It refers to the software used by attacker, and to bypass, it is necessary to modify the codes or develop new codes. So it means that the more you defend the higher level, the more effective it is. Then we have question again. So how do we find out the TTPs or tools? And it is a MONITORAPP matrix or visualization of the concept of TTP at the top pyramid of pain. MONITORAPP is a global standard framework currently composed of 14 tactics and 211 techniques. Through this framework, we can systematically analyze attacker behavior patterns and establish effective defense strategies. Each TID detail page corresponding to a technique includes examples of the procedures, countermeasures, detection method, and reference sites, allowing you to understand how the attack was carried out. MONITORAPP is a global standard for thinking and designing defense from an attacker's perspective, just like threat intelligence does. And if you look at the right bottom, there is a version of MONITORAPP, and it means that it is keep progressing. And in order to drive data to intelligence, typically go through the following process. Usually referred to as the life cycle of threat intelligence, it is the process of converting raw data into complete intelligence for decision making and action. Starting with requirements, collection, processing, analysis, dissemination, and feedbacks goes in circular form. And this threat intelligence lifecycle helps organizations systematically manage how they collect, analyze, and share information to respond to security threats. SOC and security equipment integration is one of the most practical use of threat intelligence. Since security equipment within enterprise generate different types of event logs, it is difficult to understand the complete attack flow using individual equipment alone. However, threat intelligence integrates with various security solutions such as SIEM, EDR, and NDR to support comprehensive security operations. It generates new threat logs within the enterprise, performs integrated analysis in SIEM, and improves alert accuracy while reducing false positives through latest IOC matching. Additionally, it optimizes MONITORAPP-based detection rule to expand response coverage against attacker TTPs and significantly improve security operation or efficiency. Through this approach, threat detection rate and response efficiency and enhanced, enabling rapid and accurate identification and blocking of high-risk events. Threat hunting is the process of proactively searching for potential breaches or threats that have not been automatically detected by security systems. Attackers tend to repeatedly use the same tactics, techniques, procedures, which we usually call TTPs, and attack infrastructures such as IP or domain due to cost reduction and operational efficiency reasons. By leveraging these characteristics and applying TTP and infrastructure information identified from past attacks to SOC logs, we can proactively identify similar or identical attack attempts. By analyzing and mapping information such as C2 server, IPS, malicious tools, and communication protocols used by specific APT groups within internal logs, we can also track the activities of specific attacker through APT group-based compromise artifact hunting. When a security incident occurs, threat intelligence becomes a critical tool for rapid and accurate response. During incident response, threat intelligence plays a key role in reducing investigation time through IOC and TTP analysis, identifying the scope of infections based on malware hashes or C2 IPs, and strengthening structural security through analysis of the attack campaign, propagation paths, and similar organizations. It can also track the flow of actual leaked data by monitoring the dark web or deep web. In vulnerability management, threat intelligence serves as a key tool for efficiency utilizing limited resources. Rather than relying solely on CVSS scores, it enables prioritization adjustments based on vulnerabilities actually exploited in attacks. For example, even vulnerabilities with low CVSS score are selected as priority patching targets if they are repeatedly exploited by ransomware. Alternatively, attacks that may be less frequent but can cause greater damage should be blocked as a priority. Under limited resources, organizations can proactively respond to vulnerabilities deemed to pose substantial risk. Threat intelligence provides objective evidence for security investment, decision-making, and policy establishment. Through threat intelligence, organizations can adopt a threat-centric, risk-based approach based on actual risk data they face, which clarifies the priorities of security investment items. By identifying industry-specific risk, organizations can establish customized security architecture that reflect the characteristics of their industry sector. Select solutions capable of responding to relevant threats and maximize cost effectiveness of investments. Additionally, by calculating the ROI of security solutions based on attack, target frequency, and occurrence data, organizations can qualitatively analyze investment effectiveness and support strategic and persuasive decision-making for secure security budgets. This supports the perception of security not as simple cost, but as a strategic investment. I will demonstrate the practical value of threat intelligence through frequently asked questions from actual field and their corresponding answers. Common questions from real customers include, should we block this IP, or is this file dangerous, or maybe does this affect our industry? In the past, we could only provide simple answers like yes or no. However, now we can provide specific answers backed by clear evidence. For IP analysis, we provide information about the IP's malicious status, post-attack history, and even associated APT group information. For the file, we present specific risk levels and response measures through C-type-based malware analysis reports. Additionally, by analyzing industry-specific threat attack frequencies, we can establish priority-based response strategies. Threat intelligence is a practical tool that goes beyond simple detection to provide clear guidance on why it's dangerous or how to respond, and even for simple what should we do about it. Now I will show you how threat intelligence is utilized through actual attack scenarios. Attacks typically begin with email phishing, where clicking on malicious attachments or links installs backdoors. The infected PC then communicates with CNC servers to receive additional commands, ultimately leading to the theft of credentials or confidential documents in a kill chain format. IOCs generated at each stage can be detected in real time. VirusTotal verifies malicious codes, hash URLs, and IPs through global security engines, while Shodan identifies open ports and vulnerable surfaces on specific IPs to understand the attack surface. Through MISP, collected IOCs are structured and shared with other organizations, and any that run analysis process flows, network traffic, and file modification history by executing malware in virtual environments. The APT group attacks reports compiled this way include CNC server information, malicious tool sets, TTPS target industries, and response measures, enabling comprehensive assessment to the threat, malicious nature, and associated campaigns. In fact, when abnormal behavior like PowerShell or WMI are detected in EDR, network security equipment blocks CNC domains, and SOC applying threat intelligence-based detection rules for immediate coordinated response. This is very simple example of how we use threat intelligence in real world. Now I want to share MONITORAPP threat intelligence platform, ALF version 5.04, which can do all the things in previous page. ALF is a platform that processes unstructured threat data collected from various feed channels through big data-based processing and provides through intelligence through multi-dimensional analysis and refined using advanced engines that include AI. It provides comprehensive security solutions through integration with global threat information. This is structure of AI labs. The life cycle of our AI labs is not much different from the common threat intelligence. Features a continuously iteratively process consisting of requirements, collection, analysis, processing, distribution, feedback, with core components including AI and big data-based analysis processing systems, and a web-based portal providing diverse information. In collection, various modules such as MIF, FIC, and AIS collect URLs, IPs, file hashes, and logs, and other data. In analysis, machine learning-based analysis are performed through MUD, UCC, and third-party and MOT. Processing conducts big data-based data mining and processing, while distribution utilizes API servers to distribute results through API, open data, pattern, third-party, and other channels. The web-based portal provides valuable threat intelligence by organizing various threat data, enabling proactive response to advanced threat as well as post-incident analysis and real-time information sharing. Through the AI Labs portal, we provide services including threat intelligence platform URL search, file search, hash search, URL categorization, and IP geolocation information, and file execution reports. The dashboard allows users to visually monitor all these information through metrics. Additionally, the platform provides detailed information about APT groups, including group description, targeting countries, target scope, attack method, and confirm malicious file information for each group. Through analysis of this covert cyber campaign, characteristic, and impact assessment, users can identify attack patterns, techniques, and tools used in APT group target attacks, ransomware distribution campaign, and other threat activities. The latest CV vulnerability detailed analysis and impact assessment allow users to review intelligence on the most recently registered security vulnerabilities, including attack methods, severity levels, and other technique analysis. The platform provides comprehensive threat intelligence service through vulnerability analysis and response strategy reports. Detailed analysis and response measures for each threat can be reviewed in real time, significantly improving the work efficiency of security analysts. And this is final chapter conclusion. Threat intelligence is not invincible. It also has challenges. Let me outline the major challenges currently facing across 5 key areas. In data collection and refinement, automated collection from various unstructured sources like the dark web, deep web, and GitHub, along with data quality management, is required. In analysis and correlation attack prediction modeling through learning from past incidents, automatic TTP classification using AI and machine learning, campaign identification, and industry-specific threat assessments are essential. In automation and integration, establishing end-to-end automation system with security equipment such as SOAR or SIEM is important. And for user interfaces, role-based, customized dashboards and real-time threat status provision are necessary. Finally, in government and processes, systemizing standardized end-to-end processes for collection, analysis, distribution, and quantitative performance evaluation based on ROI are key challenges. Threat intelligence is establishing itself as a core asset that supports organizations' overall security strategy beyond simple detection and response. It is essential to move away from fragmentary utilization centered on IOCs toward TTP-based in-depth analysis and automated integration with security infrastructure. Through the introduction of AI and machine learning-based analysis and real-time response systems, there is a need to dramatically enhance the utilization and accuracy of threat intelligence. Clear ROI for security investments must be presented through comprehensive performance analysis of intelligence, utilization, and integration with security policy governance. Through systematization and optimization of the entire cycle of collection, analysis, sharing, utilization, this will serve as a core element of integrated threat intelligence platform competitiveness. So this is it. This is all my presentation. Thank you for listening to the presentation on cyber threat response strategy based on threat intelligence. If you have any questions or additional inquiries, please feel free to contact us at any time. Thank you.